I wish I had a silver bullet for you for actually fixing flaky tests, but I don't. But what I do have for you is some approaches to common causes, to fixing common causes of flakiness that I hope will inspire you when you are fixing flaky tests. Now, one common thing I've seen that I think is a really good idea is to quarantine unstable tests and run them separately. And you still want your flaky tests to run, but you don't want them to block your otherwise healthy CI pipelines. So here you can kind of see a Gradle script where you have your flaky tests listed one per line in flakytest.txt, and then you can exclude tests matching these patterns in your test tasks, but then you also register this quarantined test that has retry. This way you can easily quarantine tests using test filters using Gradle. And one of the advantages of this is that you can run a very small set of quarantine tests very, very often to more quickly detect when a test has stabilized. Now, if you encounter improper time handling, I mentioned before that current time millis is not monotonic. You should use system.nanotime for calculating durations. However, this comes at a cost because system.nanotime uses an order of magnitude or more clock cycles for your CPU. It's an order of magnitude more expensive. So if you're running system.nanotime like all the time, you just want to keep this in mind. It might be better in that case to wrap, in Java 8, introduced a java.time.clock that's abstract that you can substitute in a new clock for deterministic time management. A lot of flaky tests are caused by lack of isolation, and so oftentimes tests might fail to clean up their database. So one strategy that I've seen effective is to run tests inside a database transaction and roll back at the end of the test. But for other types of leaks, you have to be especially sensitive to poor error handling in setup and teardown. A lot of times you don't see a lot of try catches in setup and teardown methods. And in cases where you have like file handle leaks, having an in-memory file system might help you prevent those leaks, leaks such as lock files and things hanging around. If you encounter flaky infrastructure, you might consider running tests that integrate with external services separately, or consider a library like WireMock that will record and playback requests and responses. Now, of course, this is contentious because you want to ensure that this works in practice, and you want to ensure that this remote service, for example, the behavior hasn't changed. So you would have to update your WireMocks periodically. There's always trade-offs here. For dynamic library dependencies, I highly recommend that you adopt Gradle's dependency locking. That's been in Gradle 4.8, I think, and above. And this also has the benefit of making your builds reproducible. Performance tests is a type of test that we've found to be especially flaky here at Gradle. So we switched to a Mann-Whitney U-test with a high confidence value to avoid too much fluctuation so that we can be really confident that there is a regression. But at the same time, you still have to be aware of non-obvious differences between your test runs and instances. For example, I have a funny story. There was a time where we still had a lot of flakiness even after introducing this Mann-Whitney U-test. And after digging and digging, we analyzed the temperatures of CPUs on our test machines were too high, and they caused the CPU to sample the cycles and caused flakiness in our performance tests when the computers got too hot. In summary, retrying your tests in the same exact environment is a simple and effective way to ease the direct pain caused by unnecessary build failures due to flaky tests. To ensure your stability and good culture around testing, though, you have to prioritize and fix those flaky tests. Gradle Enterprise will help you by collecting your test history across all builds, not just CI, and giving you peripheral analysis tools to understand how many flaky tests you have, how often each one is unstable, when they start becoming flaky, when they become stable, and so on. And you can also analyze common traits between flaky test runs and also use build scan comparison to compare the differences between stable and failed runs. So I've written some blog posts here. You can reach them at blog.gradle.com. There's also a short link here for Gradle's test retry plugin. So if you'd like to learn more, check out these blog posts, or also, of course, you can submit your questions to me. But I hope you found this session inspiring and informative. I want to thank you for your time. And now I'll move to answering questions.